personally was trained as a historian. So I ended up as a historian, as a system administrator. Of course, like everyone in my generation. So I'm not very surprised that today I introduce to you, you're not a doctor yet, are you? No. Right, Dr. Randis in chemistry and an aspiring doctor in philosophy, right? So he, of course, talks about computers, right? And I read his website and he says, people over servers, understanding over execution, integrity over shortcut taking. Well, yes, right? So, do you remember that somewhere during your career, and for some of you is that quite a long time ago, that you took an assembly class, a 6-month assembly class, and you still wake up every now and then sweating and think of that class, right? And for those of you that do not, well, here's your chance, because we're talking about WebAssembly now, right? So, Alessandro has 45 minutes to tell us about its usefulness and why you would want this. Thank you very much.
Yeah.
The floor is yours.
Yes, indeed. I was a chemist in another life. I was a sysadmin of the chemistry department, and I was running Linux in 1999. Slackware 0. Oh yes. So. Yes, can you hear me now? Yes, yes. So, chemistry department, University of Ferrara in Italy. I'm Italian. Sysadmin. So I started to install Linux everywhere. And then the IT department of the university came down, looked at me like, what are you doing in this lab? You are patching things, you have no idea what you do. But I actually had a lot of ideas of to run the chemistry, the IT of the chemistry department. And I didn't get an assembly course at the time, because in chemistry we learn Fortran. Who knows Fortran? Yes, because, wow, okay, that's impressive. Because it's the language of science, right? So there's all those scientific packages for Fortran. And so that's where I started looking into Linux, and that was 1999, or about that. So there won't be a lot of assembly, because it is called WebAssembly, but there's a catch about it. That's me. So I just recently switched to Blue Sky. So if you're on Twitter, I urge you to get out of there, because it's a reactionary platform, and we are hanging out at Blue Sky, and it's pretty cool. So we're gonna talk about, I'm not sure I'm gonna use the whole 45 minutes. There's a little demo in it, but let's see if we get there. Also, I'm the last one, so it's between me and the drinks. So let's see where it goes. So we're gonna talk about what is WebAssembly and why it matters, and maybe show you some cool stuff. It's me. I'm Alessandro. So I was at NLUUG 2013, all 11 years ago. I think I was at the beginning of my career. I was at Red Hat at the time. I was doing OpenStack before Kubernetes came out. And then, of course, when Kubernetes came out, I was at Red Hat. I started working with OpenShift, never looked back. I organized the Dutch Kubernetes meetup. In fact, we have a meetup tonight. That's why I cannot stay for, I have to rush back to Amsterdam for a meetup. And because of my work in the community in the Netherlands, I actually started the DevOps meetup 12 years ago, and then moved to the Kubernetes, the OpenStack meetup, and then the Kubernetes meetup. I'm a proud CNCF ambassador, so I kind of talk about what CNCF does all the time. I just been nominated, by the way, technical lead of the technical advisory group, the TAG, environmental sustainability. So maybe another day, maybe without waiting another 11 years, I'll come and talk about what we do within CNCF when we talk about sustainability of software, especially the cloud-native software that we all love and use. And I'm working on a little interesting project called Kubespaces. If you want to know more about it, you can find me. It's a startup, because it's nice to have a startup. And enough about me. So WebAssembly. Who here is a Rust developer? Wow, okay, cool. C, C++, is better. JavaScript, maybe. All right, okay. So I'll start from the very beginning. So WebAssembly is a WT3C standard, right? So it's the definition is a standard for binary instruction format for a stack-based virtual machine, right? So it doesn't. It sounds like a very abstract, very complicated, but in fact, it's a form of a bytecode that compiles code into a format that machine can understand. So assembly, that's the only assembly you're gonna see today. So this is something that it's not even the final thing that the CPU understands. So this also needs to be translated into machine code. But this is a very low level abstraction over a program, a software. And it looks like this, like nobody can understand what this does until you actually see what it does. So WebAssembly is an intermediary format, bytecode, that is actually interpreted by the WebAssembly virtual machine that can run in many places, including, of course, in the beginning, it was only the browser, and now can be executed outside the browser into many places, like servers, that eventually runs that into machine level code. And so you get portability, so you can compile once, and that's the dream of the WebAssembly standard, is to compile once and then reuse it everywhere. So you don't need to compile for ARM, you don't need to compile for RISC or x86, you compile to WebAssembly, and that magically runs everywhere, because the virtual machine that that runs in your browser or your server or your phone or anywhere understands WebAssembly and translates that into machine code. So you see it supports a number of languages. So you don't actually learn WebAssembly. It's not a language per se. You learn Rust, you learn Go, you write your software in, even Python compiles to WebAssembly. And you use WebAssembly as a target for your compiler. So it's the compiler that doesn't compile for a specific architecture, but compiles for WebAssembly. And then you delegate to the virtual machine that runs wherever, in your browser or on your Kubernetes nodes, for example, as I show you. You delegate to that to translate the WebAssembly to machine code. So you get this, that it's a very powerful paradigm, it's a very powerful idea. So much so, Solomon Ikes, who was the guy who created Docker, even stated that if this existed before, you can tell the difference, right? So if you replace WebAssembly with Docker, it's kind of the same thing, right? So it's the same promise of portability of containers. Containers take your code, compile it or squeeze it into a container image, and that image can run anywhere that that code can run, of course. So the Docker format doesn't make an assumption or doesn't translate your code for an architecture. It's still, if you compile the Go for x86, you put it in a container, still it's a binary for x86, while WebAssembly goes one step further and even abstract away the intricacies of the architecture. So if this was there when they came up with the Docker, we wouldn't have needed to run containers at scale. We would run just WebAssembly modules. Unfortunately, it came out only in 2017, so almost 9 years after that. But there's still time, and now I think there's a increased interest in WebAssembly. So why it matters? Because first of all, it's polyglot, right? So it compiles code from all sorts of different languages, and I'll show you the supported languages. It's safe because it's like it's a sandbox environment. This virtual machine here can be made secure, and it is secure because it runs in the browser. The browser, notoriously, it's unsafe environment, right? So all the JavaScript, Java virtual machines, they run in virtual machines because they get isolated from their environment. There is a very clear separation between the runtime and the system interface. So it is very safe to run WebAssembly because it's designed to run in unsafe environments like browsers. It's portable. You can take the same module, compile once, you distribute it to wherever, and I'll show you the same application runs on my phone, runs on my computer, and so on. And it's open, so it's an open standard. It's a W3C, so everybody conforms to the same. It's an ecosystem of tools and compilers that all work together. So it's the big promise of, this idea of I don't need to recompile, I don't need to write again the same thing over and over. I write it once, and I can just distribute it, run it anywhere I want or I need. Most of the developer, of course, is in Rust. Rust has particular interest in WebAssembly. Rust plus WebAssembly is one of the most popular combination now, but it's not limited to that. C++, Go, they all have build tools, pipelines, compilers that can compile to WebAssembly, especially Go, since 1.21, I think, supports native compilation to WebAssembly. And the funny thing is, JavaScript is there, but JavaScript doesn't compile to WebAssembly. The reason is JavaScript is it's not a strongly type of language, while WebAssembly, I'll show you in a moment, only understand integers. There is no string in WebAssembly, so it's a very strongly typed, and compiling JavaScript to WebAssembly just doesn't work. You have to compile also the compiler in WebAssembly and then run together. So, but that's a bit getting ahead of myself, and there is some more stuff, of course, I'll show you in a second. Well, like you can see the supported languages, and I'll switch the browser sometimes because there's a lot of stuff that I want to show you next to the presentation itself. So you see, this is from Fermion. It's one of the companies that does the most in the space. You can see there is a lot of languages in there. Even COBOL can be made to run in WebAssembly, Erlang, and so on. And if you still code in pair, there's maybe a chance you can run this in your browser as a WebAssembly module. So this is WebAssembly. That's how it works, right? So nobody writes this, of course. Nobody writes binary or assembly language. I hope not. And even nobody writes pure WebAssembly. There are website out there like writing WebAssembly by hand. If you really want to, you can understand what it does, and you can actually write yourself. But most of the time, you write a Rust program, you write a Golang program that translates into this, compiles into this. And there are two ways to represent a WebAssembly program. One is the binary. You don't want to see that. And one is the WAT, the text representation. They are completely equivalent. They are the same thing, just that one is more easy to understand, even if it's quite hard to write yourself, especially if this becomes pretty big. But you see, it's all in parentheses, the module. So a WebAssembly program is called a module, and this is called S representation. So it's like a tree of functions and parameters. They're all inside each other, right? So this, this parameter is inside this function, and the function is inside the module. So the module contains two functions, and each of them contains a number of parameters and function themselves. So, and they can call each other. So the function +1 calls the function add, and so it depends on the function add. So it's internally the virtual machine builds the tree of functions that compose a module. So what you do, you write some code, you compile it into a WASM module, and it's ready to go. It's ready to be executed. What you need, of course, sometimes, or if you want to run it in the browser, is some glue code, some JavaScript, some HTML that actually downloads, the browser downloads the WASM module and runs it in the browser, right? So it's not server side, it's not something, it runs in your browser. And this is how it works more or less. So there are functions, the function return a value. For example, this one just returns one single static values, which is 42. You see that in WebAssembly, there are only integers. There is no idea of a string. The strings are represented as pointers to memory, so it's a bit complicated to write yourself. I've never done it and don't think I will ever, but I'm happy to write higher level languages that then are translated to WebAssembly. I can look at the code, I can kind of understand what it does, and it's a state machine, or stack machine, sorry, a stack machine. So it put data into the heap and then takes it out, calculates, and then put it back. It's kind of, I never study, I told you, I study chemistry, so no computer science for me. So these ideas are fascinating, but really abstracted for me. So I don't know what a stack machine really is. I do understand that it's a way to calculate functions like this, but I don't really understand how it works. But I don't need to, because I can just write high-level object, high-level programs like in Go or Rust, and then let the compiler take care of that. I can show you some things that, so why this matters. Okay, so why it matters, why everybody's hype about WebAssembly. Well, it runs in a lot of places. Even you can write like plugins for, I love Flight Simulator. I didn't know. Actually, you can write plugins for it in WebAssembly. The old Photoshop in the browser. So Adobe last year announced that they ported the old Photoshop in your browser, in WebAssembly. Istio, I used to work a lot with Istio. Istio is a service mesh for Kubernetes, intercept requests coming into your cluster, like an ingress, and it can execute a little WebAssembly module every time there's an ingress and do something interesting with it. So it's like a plugin system. Bacalhau, also very cool, runs these distributed WebAssembly modules everywhere, even in a satellite or a submarine. Everywhere you can run code, you can run WebAssembly modules. I collected some interesting things to show you. Of course, this is Photoshop. I don't have an account, so just trust that this is Photoshop in the browser. This guy, WASM4, has a bunch of games, and there's one that I really like. So this runs in my browser. So my browser is actually executing continue, 2 players, I don't know, it doesn't work, so not bad. X, yes. So this is all running in my browser. I clearly not really good at this, but so you can also check for yourself, and of course, obviously, so this runs completely in the browser. If you can believe that, you know. So it's very important, and this is a SSH client. It's pretty cool. Can connect to my server. It's crazy, right? So all running inside my browser. This is a Vim completely running in my browser. Now I cannot exit, of course. Yeah, I can. I guess I can. But yeah, it's a full Vim virtual machine. It's a virtual machine in my browser that runs a smallish port of Vim compiled for WebAssembly. This is an cool stuff is WebAssembly Studio is actually how you can learn, but also this runs completely in the browser. It's like an editor completely in the browser. This is actually really cool. It's a squash, so you can, all this stuff will require probably like a progressive web app or a different technology or more a native client for my Mac can completely run in the browser. And what matters, this is so cool. This is a full Windows 2000 virtual machine running in the browser as well. So it takes a few seconds to run. I know that, but yeah, if you were around, completely workable. It works. It just probably you can calculator. Probably everything is there. So if you need to try something with the Internet Explorer, it takes some time, but who remembers this? And this guy, actually, this guy works at Microsoft. He wrote an entire emulator of an operating system, a desktop OS, in the browser. And of course, he also runs Doom, because why not? And he got a lot of interesting stuff. The guy works at Microsoft, is David Brett, I think, Dustin Brett. And it's really interesting. So, all this stuff, no server involved. It's something that my browser downloads locally and runs it. So imagine what you can do with this. Imagine if you can, and there's of course, like coming up with a good application of it is like running LLM inference in your browser. You don't need to every time talk to an API. You can actually run this in the browser. There's a project from Microsoft again called Onyx. For the Onyx Web, I don't remember, so there's Onyx and then Onyx Web. It's basically running this runtime in WebAssembly in your browser, so you don't need to have a server somewhere. You can just leverage your local resources to run inference and so on. You can also use GPUs. It's totally possible. If your machine has a GPU, even in your browser, you can access the GPU from, if you allow, of course. This is the support. Of course, we saw this. This Blazor, also web framework from Microsoft, also compiles to WebAssembly right out of the box. And of course, if you are a C developer, C, C++, there's the mscripten, which is a tooling to compile to WebAssembly. Most of the time, I mean, most of the development is done in Rust. I'll show you something with Rust. But then, that's only one runtime that I show you, the browser, which is great. Of course, everybody is a browser, but it's not running everywhere, right? So maybe there is more than a browser out there, and that's why in the last few years there are a bunch of runtimes that have been popping up, right? So WASM Edge, it's very interesting, also a CNCF project. The problem with the runtime is it's always like, how do they access system resources, like file system and network, and that's the role of the WASI, the WebAssembly System Interface, which is an attempt to standardize access to system calls, like access a file system or network, for WebAssembly modules. And that's is an ongoing project. There is a bunch of implementation coming up. Actually, I think I have somewhere. Yeah, and so this is, unfortunately, I noticed this. This is a very cool runtime. Unfortunately, from the guy from Ukraine to stop development. These are the proposals for WASI, right? So you can see here, there are a few already in implementation phase, so I/O and file system and sockets. Some cool stuff like implementing a key value store right in WebAssembly, right? So, and then offer it as an interface to your software, and also some other stuff like messaging and SQL as well. So WASI interface for SQL for your WebAssembly code. What else? Of course, did I miss something? No. Ah, no, there was one demo that I want to show. This is how to is it better than JavaScript? Also, JavaScript runs in a virtual machine in your browser, right? So you can do the same, right? Well, but WebAssembly runs in a very specialized, very optimized virtual machine that is much faster. How much faster? This is how to calculate Fibonacci numbers up to the 35 number, and it takes 30 seconds with WebAssembly and about, millisecond, and about twice as much in JavaScript. So it is faster and is safer because it runs in an isolated virtual machine. So you get these runtimes. Now you need to run them. So, and now, of course, the WebAssembly is governed by the Bytecode Alliance, which is I don't know if it's Apache, but it's an open source foundation that takes care of the development of WebAssembly. But of course, the interest of another big one, foundation like CNCF, it didn't took long before we also got interested in this. So there are a bunch of CNCF projects, and if you go to the infamous landscape, there's even a switch. You can see all the WASM-related projects like Knative, and all these projects more or less interact with WebAssembly. For example, Istio has a WebAssembly plugin system. And many others are part of the landscape of Cloud Native Computing Foundation, especially things like WASM Edge and WASM Cloud. So, of course, like a Cloud Native, always been about containers, right? So containers are the bread and butter of Cloud Native infrastructure, right? So it's the whole point of having Kubernetes is to orchestrate containers, right? Sure. But there are reasons why maybe you want to look beyond containers. It's not just containers out there. It's more about how can you efficiently run your code at scale. Not only efficiently means, yes, you save money, but you may also save the planet in the same stroke. Because if you run smaller piece of computation, smaller units, maybe you need less resources. You can descale, degrowth, instead of just buying more servers and more stuff. Maybe you can do more with less, which is the whole point of sustainability in IT. So containers are bigger, of course, bigger than a WebAssembly module. Smaller than a VM, sure. Smaller than just the way we used to do before containers. But still, even then, WebAssembly modules are even smaller than those. They start faster. WebAssembly starts in near real time, near instant. They are more efficient, and they are more portable. So there are reasons to look beyond containers. You do need to recompile stuff, of course, because now instead of targeting an architecture, you're targeting this meta architecture of WebAssembly, but it's worth the effort. There are things like Crustlet, which is a port of Kubelet to Rust and to run WebAssembly modules. The KWASM operator, which is like an operator that simplifies the deployment of this WASM modules into Kubernetes, and SpinKube, which I'm going to demo if I have time. So you see, this is the runtime class. It's a thing in Kubernetes that specifies which container runtime that pod is going to run. So instead of the classic containerd, you can define a new container class that refers to WASM Edge, which is the container runtime for WebAssembly. And so this pod, it looks like a regular pod, but instead of a container, it's actually running a WebAssembly executable, a WASM file. And because the magic of OCI containers, the Open Container Initiative is this format that everybody use and every registry conforms to, where you can push a regular container image, you can push an Helm chart, you can push a WASM module, the same way you do it with Docker images. Just the artifact change, but the registry is the same. WASM Cloud, also a very cool project. It's kind of a serverless platform, right? So you get HTTP request, your components, your WASM modules are spin up upon a request that comes in. Short demo, why not? What can go wrong? Any question in the meantime? No, okay, so, well, I have a K3D cluster. So I did the demo, so I didn't want to bother you with the K3D, blah, blah, blah. So notably, I created a registry, so because I need to push my image, and I added a node. And the node uses a specialized image. So it's a node in K3D. K3D is a kind of a local Kubernetes cluster thing, of course. 1 second, let me reconnect. Yes, you can see, right? So I have three nodes. One is the master, of course, one is the control plane. The other one is the agent, and one is the spin node, the node that is created with this command, and it got like a specialized image that contains not only containerd, but also the shim, the wrapper around spin. I installed spin operator, which is this one. Wait, did I install spin operator? Maybe not. Okay, let me install this stuff. Doesn't artify, install it again, it doesn't really matter. So it's just what we need is cert manager to create the certificates for the operator, and especially the run class. Maybe there was an error, so okay, demo goals are not with me. One thing I want to show you, of course, like this is in the spin node. Containerd also has extra. It's not just a regular containerd, as a spin container shim. So it means that if I get a runtime class, see this spin runtime class means that I can now run pods. They look like pods, but instead of containerd, they're gonna call the spin shim. Now, Spin is this project from Fermion. It's very cool, and it lets you scaffold a new project very simply, with just one command. With this spin new accept default, blah blah blah. I call it link cluster. It just creates a folder called link cluster. Inside of that, there is a Rust project, of course. And is, of course, this is the old Rust code that I'm gonna turn into WebAssembly module. So with this command, spin registry push -k because it's insecure. I'm running a registry myself. I'm running a registry in my own machine. ---- build. So it's gonna build the WASM module and push it with one command. And this doing cargo build and so, cargo build, but targeting WASM, of course. So it's pulling all sort of stuff from the Rust ecosystem, from the modules, and then it's pushing to the registry, right? So, and now I do have release. Yes. So this is my WASM executable, which is now an image in my registry. So I can, and the beauty of this spin thing See, I don't have, now I just build it and push it as an image, and also got this kube scaffold, right? Which creates an app.yaml, which is it's a CRD called spin app, which will deploy this image, spin cluster registry, link cluster 00010. So I can just apply this, finger crossed, of course. Yeah, something, the operator didn't. Okay, sorry guys, sorry folks. It did work on my machine, it's the same machine. There's some reason why the spin operator of course watches over this object called spin up, mount volume. Yes, let me do it again. I think I know what it is. Maybe I know what it is, maybe not. Maybe I'm just headless chicken looking for a solution. So the spin operator is this thing that just watch for this, this spin up objects and then creates a pod according to that. But if everything is all right, where is the spin operator? Yeah, running. Okay, let's try again. Yes. So now I have a spin up. I have a spin up and I have pods. 2 pods running. What are these pods doing? They are running my. So this image here is not a Docker container. Yes.
You've lost me. How many levels deep are you in?
I'm just 1 level. So I created the spin up that is pulling my WASM module. Is actually running as not as a Docker container, but as a WebAssembly module. And now you know this. I mean, how can you tell? Because this image is what I built out of my code as a WASM module. So that's the whole idea. Yeah. So I get this. Of course, I also have a service, which I can expose. I know I go very fast because that's me. I'm sorry. But this is my code served from hello Fermion, of course. But let's say that I don't like Fermion. I like it, but I want to change it. And this is my code. This is the code in Rust that just runs a HTTP server. And I change it to, okay, I got 5 minutes. And then I do the same command as before, so spin registry push. So it's gonna rebuild it with the new code version, push the new version to the registry. I do the scaffold again, of course. So I just now this app.yaml. Yes, I made a mistake. Here, also 1.1. So now my app YAML has the updated version, and I can just apply. Right, and so my pods are now being terminated and restarted, all through a single CRD called spin up. So spin is just a way to need to do port forward again, and you can see that now is the new version of the application is online. So that's the wrapping up. I'm sorry if I lost you, but so the whole point is this pods are pods. They look like pods, but are not Docker containers. They are WASM module, and they can run on a server. In this case, a Docker container, but it could be an AKS cluster or whatever cluster. And so that's the idea. So that's me. That concludes the whole talk. If you have any question, I'm here for another 10 minutes, I guess. Or if you want to play Doom, also possible.
Yeah, I have one simple question.
Yeah.
You have a Blue Sky account, but can we also follow you on Mastodon?
You can, I guess. I mean, I think I have an account there. But so
please post something there.
So
it will be interesting.
Kelsey Hightower, the guru of all Kubernetes people like me, he just quit Twitter and went to Blue Sky, so we all follow him. You know, it's, but also because, I mean, Elon Musk. I don't have Mastodon. I do. I think I do. Yeah.
Okay, first of all, thank you for your talk. It was really interesting, and it showed me a lot of applications for WebAssembly. But was one thing that I like to remark is that you made it look like that all these languages are generating WebAssembly right now. And of course, if you use Rust, you can generate WebAssembly code. Yes. But there is in between, as far as I know, but I'm not sure, there is this LLVM project that is actually generating the WebAssembly code. So there is an intermediate language which is generated from Rust, or maybe even from all the other languages. And that project is a derivative of the CLang project.
Yeah.
And well, you didn't mention it at all, and they have a really big influence on this whole development. So I like to mention that.
I'll clarify. So LLVM is a very old project, right? So it's a build toolchain for C programs, C++. But I don't think Rust compilation to WebAssembly use LLVM. It does? Okay, then my fault. Yeah, so LLVM is the magic sauce that actually understand how to compile into WebAssembly. Yes, of course. Yes. Emscripten, again, because I'm not a C developer, so it's kind of a black box to me, but emscripten is this command, emcc, but you do have to have LLVM to compile C to WebAssembly.
So you showed Doom running. Did you know that Doom 3 can also run in the browser using WebAssembly?
WebAssembly, okay, that's Doom 3, I mean the good one, yeah. So.
You say that it's more efficient than a container, but I just want to clarify. I think the straight line performance of pure compute is like at least 20% worse in WebAssembly, and for some workloads it can be as much as twice or 3 times as slow. But the thing that's faster is the context switching. So if you make system calls, all of the system calls are much faster in WebAssembly compared to in a container if you've set it up nicely.
Okay, that's I mean, of course, there is a VM in between the WebAssembly module and the kernel, right? So that it could be slower, but it's definitely smaller, and it loads faster.
It's definitely smaller. Yeah.
Definitely smaller. So faster is maybe.
Yeah, like if you measure like the CPU time of doing like a major transform or something, you're going to find it significantly worse in WebAssembly than a container.
Okay. Yeah, but browser don't run containers. That's the point. Yeah, I'm referring to
the comparison to like.
Yeah, that's true. That's true. Totally, you get a point. Sure. So yes, it's not faster than a container per se. I didn't say that. I say more efficient, as in use better the CPU than a container. But yeah, it's the idea. So one more.
Yes, I'm very old. I was taught how to program in 1982, actually by the guy who's sitting next to me. And I once went to a conference where, you know, this whole idea of compile once, run anywhere was presented, and it had a name. It was called Java.
Yeah.
So why redo Java? What's the difference? Why not just use the Java virtual machine? What changed?
That's a good point. So, but it only compiles Java. That's one language. Wait a second. To the JVM. Okay. Somebody wants to help me here?
Yes,
Ah.
exactly.
So at least one difference in design is that Java virtual machine bytecode has an object model built into it, whereas the WebAssembly bytecode, at least for WebAssembly 1.0, is really basic. There's just 32-bit integers, 64-bit integers, 32-bit floats, 64-bit floats, and arithmetic, and a load, store, and calling a function pointer, and that's all of the operations. So I think that from, WebAssembly was designed with the security model in mind so that it could be run in browsers where they have very strong isolation guarantees. And it was designed to be as, also Java. Yeah, sure.
I think that this is maybe a bit outside the
So I wish I had popcorns, but I have straw waffles, so
Right.
that's.
One more question, final question. No, thank you very much.
Okay,
Thank you
thank
very
you.
much, Alessandro. I've got real Dutch stone
Really?
waffles.